Hello! In this example, we're going to play around with some curve fits and trying to figure out what's the best curve fit to use for our predictive data. Okay, so the Lynx company sells its golf clubs at golf outlet stores through the United States. The company knows that demand for its clubs vary considerably with its price. In fact, the price has varied over the last 12 months and demand at each price level has been observed. The data is in the estimation sheet for Q1. For example, during the past month when the price was $390, 6,800 sets of clubs were sold. The demand is in hundreds of units. So it would say 68 instead of 6,800. The company wants to estimate the relationship between demand and price and then use this estimated relationship to determine the best price of the clubs. So we've got two things going on. What is the best forecast equation to predict demand as a function of price? And we're going to consider three separate functions: a linear curve fit, a power curve fit, and an exponential curve fit. We're going to evaluate the accuracy using two forecast error equations, MAP, which stands for mean absolute percentage error, and MEA, mean absolute error. And then question 2 is we're going to pick the best equation from question 1, and then we're going to figure out what price that we should be using to maximize our club price. We're going to be doing that in multiples of 10. So let's go to our estimation. Okay, so we've got our demand for golf clubs, our price, and our demand. And so we've got to do this three different ways. We have to do a linear forecast, a power forecast, and exponential forecast. So what am I talking about when we're talking about these different kind of things? Now, a linear forecast is a straight line. It will be demand is equal to A, which is our linear intercept, plus B, which is our slope, times our price. So power forecast is kind of the same thing, except we'll be using a power equation. So it'll be set up in the form of a constant times the price raised to another constant. And the last will be an exponential forecast, which is going to be a constant times E raised to another constant times that price. So it would be demand is equal to A, E raised to the B times price. So these are kind of difficult things to do just with the numbers. If we wanted to use MATLAB and stuff, we can, code it in and do it. Fortunately, Excel makes trend fits actually pretty easy. So Excel calls their curve fits, they will be called trend lines. And so they kind of trend the data. And it will calculate it out and give you an equation. It makes everything nice and easy. So let's go and do that. So what we're going to do is we want to graph the price versus the demand. So we're going to highlight those. We're going to go insert. We're going to go here to our chart for the XY scatter, and I just want the data points. Okay, so here we go. Even though we're just using this to take care of some initial stuff, we still want to make it a proper graph. So we're going to call this the linear trend, because it is going to be the linear trend line. And then I'm going to add axis titles because we need axis titles in units. So the axis title down here is going to be price in dollars. And then this here is going to be, actually I accidentally shifted that, so I'm going to hit, there we go. I just undid it to put it right back in the spot. And this is going to be demand in hundreds. Okay, so now that is all exactly the way it should be. I'm very happy with it. So now we want to go through the process of doing the curve fit. How am I going to do that? I'm going to right click on the data and I'm going to go here and say add trend line. I could also hit the plus here, go and add a trend line. I can go into design, add chart elements, and add a trend line. So there's a lot of different ways that we can end up doing it, just like everything else in Excel. So I'm going to go here, I'm going to go add trend line, and it's going to pop up this little format box here. And you can see that there's a couple of different trend lines that Excel does by default: exponential, linear, logarithmic, polynomial, power, moving average. If you want to do some kind of curve fit outside of those, you're going to have to go into some MATLAB or some other method. Truthfully, this is more than you should need for everything. So we're going to start with the linear one. And you can see the little dotted line in there. So that's our trend line. It is the best linear fit for the data. What we want to do is we want to display the equation on the chart, because we are going to want to know what the equation is. We have this r squared value that we'll actually talk about a little bit later, but this is basically a value telling you how well that curve fits, if you want to just think of it that way. But we don't need that right now. We're just going to do our linear. I'm going to pull it down here so I can actually see it. And so there we go. And I'm going to come over here because I've got my parameters of the equation. So my intercept is 211.31 and my slope is negative 0.3546. Okay. And so now I got to do the other two. I'm not gonna cheat, but I'm gonna be kind of lazy. I'm gonna go right click, copy, right click, just paste, keep source formatting. And why did I do that? So I don't have to put all this other stuff in again. So we're gonna change this. This is gonna be our power trend. And then I'm gonna come here. I'm just gonna click on the trend line. I'm gonna delete that, and then we're gonna redo it. So add trend line, and we're gonna go for the power display equation on chart. I'm going to pull that down here. Now, an issue with this, as we can see, because since this is an exponential, it's kind of hard to, because it's actually not just really the 6e to whatever. And so if I do change that to just number now, instead of just general, you'll notice it expands it out. And so there's a big difference between, there was 6 million there and 5.871 million. So that's what we want to do. Okay. And so our constant is going to be that 5,871,064 into 0.2. And I like having commas on those really big numbers, so I'm just going to go put that comma in there. And then my exponent is going to be negative 9.91. Okay. And so that is the information that I need for my power trend. So we're going to do the exponential trend. Same thing. Copy. Control V. Paste. And so there we go. I got my, everything's already in there. So we're going to change this to exponential. Yeah, get rid of that. Let's drag the screen over. Oh, no, that's a little too much. Drag this over just a little bit. I am going to kill that trend line, and then once again we're going to right click, we're going to add a trend line. This time we're going to go exponential. And then display equation on the chart, and then once again I'm going to move that down just so I can see it. And so there's our exponential equation. So we're going to come back over here, and our constant on that is going to be 466.51. And then if we look, our exponent is negative 0.005. Okay, so now these are our best fitting parameters. And so now what we're going to do is we're going to do our predictions. Now, I am going to be dragging information down here, so I am going to want to either we'd have to put in dollar signs and lock things in, or we can give these guys range names. I'm going to give them range names. Now, the problem is these both have constant and exponents in them, so that's not going to work because you can't have two things named the same. So we're just going to call this, I'm going to rename this to the E constant and the E exponent. And actually, I didn't need the underscoring because it's going to put that in on its own. So we'll just do it that way. And so now what I'm going to do is I'm going to not resize that. I'm going to select, and we are just going to grab all those formulas, create from selection. We want to grab the stuff in the left column. Now as I look at that, I can see, okay, the names are all put together. Okay, so let's go. So for month number 1, we need to calculate out our linear demand. So what is our linear demand going to be? Well, our linear demand is going to be the intercept plus B, our slope, times, and then from there, we are going to multiply that by the demand. Excuse me. We're going to multiply that by the price. We're doing demand. We need the price. So the price for month 1 was $450. And I'm leaving that one fine because I am going to drag it down. And I want it to go. So our demand is going to be $51.75. Now, I'm going to do all 3 of these and then just drag them all down at once. So now we do the power equation. How's the power equation? It is our constant times the price raised to our other constant. So this is going to be our constant times, and we're going to grab our price again, and then we are going to raise that to our exponent. And so the power prediction would be 50.24. Last one, we'll do the exponential. The exponential is going to be our constant, times, we have to do e. E is that little irrational number. It's about 2.17, and then it keeps going because it's irrational. The way that we do that in Excel is exp, and it returns e raised to the power of, now it's a function, so we're going to use the brackets, so that everything in the brackets is going to be e raised to that power. And so in this case, for our thing, we need to take the e exponent and then multiply that by the price. Okay, and so the exponential is going to give us a prediction of 49.17. Now, the real demand was 45, but once again, we're trying to curve fit this as best we can. So now what I'm going to do is I'm just going to highlight all 3 of these, and I'm going to drag this down. Now, I could just grab it and drag it. Another cool thing Excel does, there's data right here in this column, and it ends right here. So if I go on that grip and just double-click here, Excel will drag it down. Now, the thing is because there's data over here, it kind of kept dragging it down, so we'll just clean that up, and we'll just delete that out. Because it usually will just keep going, and then when it stops, it stops. Okay, so we've got our predictions set up, and that's where we're going to end this video. In the next video, what we're going to do is we're going to actually start evaluating which of these is the best based on this may and MAPE idea, and we're going to choose which function we have that is the best, and then we're going to use that to create our profit model.